able to apply the concept to yours. So mine says 7x over x squared minus 25 minus 8 over x minus 5 equals 1 over x plus 5. So this looks complicated, but we're going to start out just like we did the past problem. So my first step is to find the LCD. Okay, and I'm going to put a little note to factor any needed. Okay, all right, so my denominators here are x squared minus 25, x minus 5, and x plus 5. So which one of these needs to be factored before I can do anything?
X squared minus 25.
Yep, and it's been a couple weeks since we did this, but how does that factor?
X plus 5 and x minus 5.
Yep, so this was that difference of squares, right? We just have two terms. And then I still have x minus 5 and x plus 5. So when I'm looking at the LCD, what is in common?
X plus 5 and x minus 5.
Yeah, so I'm just writing those one time. So I've got an x plus 5 in common and an x minus 5 in common. And that's your LCD. Okay? Don't have to write it twice. Now, so that helps us get that LCD part, which is going to be crucial because our next step is, step 2, is to multiply every term by that LCD. And this does take a little writing, but I promise you that it's worth it. Okay, so just bear with me. When I write this first term, I'm actually going to write it in factored form, x plus 5 times x minus 5. And that's going to help me out. So watch carefully. LCD comes first. That was x plus 5, x minus 5. I would suggest writing small for this. And then I'm going to put this first term beside it multiplied. So 7x over x plus 5, x minus 5. Okay, bring down the minus sign. And I'm going to do my LCD again. My LCD was x plus 5, x minus 5. And I'm going to bring down the 8 over x minus 5. Bring down my equal sign. LCD again, x plus 5, x minus 5. And bring down the 1 over x plus 5. So just looking at this, we can see we've got the LCD times the first, the LCD times the second, and the LCD times the third. Okay. That is a lot of writing, but it's just writing. You haven't had to think much about what we just did, but now we're going to have to think about why we did this, okay? So my next step is to cancel. Why am I doing this? Why am I multiplying by the LCD? Well, the reason is because I don't know about you, but I don't like fractions, and mathematicians don't like fractions. I know we teach math, but we don't like it. So we come up with ways to get rid of them, and this is one way. So what happens when we multiply by the LCD? Well, wonderful things happen. Things start canceling out. And so one conceptual thing you need to understand is that this x plus 5 and x minus 5 is really in the numerator of a big fraction. So the x plus 5, the x minus 5, and the 7x are all in the top. And the x plus 5 and x minus 5 here is in the denominator. So if I have the same thing in the top and same thing in the bottom, they're going to cancel out. So here, both the x plus 5 and x minus 5 cancels. Okay. What cancels in this second set?
X minus 5.
Yep. And in the third set? X plus 5, right? Okay. So now all I have to do is write what is remaining. So I'm going to put rewrite. Rewrite. So we're going to make this look better. So now that we've canceled everything in this first one, I just have 7x. I'm going to bring down that minus sign. Be real careful. People forget to do that, and it messes the problem up. I'm going to put the number that's by itself first, then the factor. So 8 times x plus 5, the factor remaining, equals the number, which is just 1, times x minus 5, which really is just x minus 5. Is everybody good with me writing it like that? Everybody understand? 1 times x minus 5 is just x minus 5. Okay. All right. So going from the first step to the third is the hardest part. From here, not too bad. What type of equation is this that I just wrote? That's a hard question, I think.
Is that the linear equation?
Linear
Very
equation.
good. Yeah. Linear. So linear, if we have linear like we do, how do we know it's linear, by the way? Oh, that was a harder question, huh? Okay, it's linear because all the x's have an exponent of what?
1.
1. Okay, linears, all my variables just have an exponent of 1. Okay, so if I have an exponent of 1, I'm going back to like unit 1. Let's just solve this. So 7x minus 8x minus 40 equals x minus 5. Combine like terms, I get negative x minus 40 equals x minus 5. Careful here. Negative x over here, that don't cancel those x's out, equals negative 5. Add the 40. I'm running out of room. Negative 2x equals 35. Did I do this right? Yeah, I did. Okay, and then negative 2, I'm just going to rewrite here. Negative 2x equals 35 divided by negative 2. X equals negative 35 over 2. That does not simplify, by the way. Okay, I have to put check answer. Okay, this is huge. Check answer in LCD. It cannot make the LCD. The LCD cannot be equal to 0. All right, so we did all that. We got a potential answer. It's not the real answer until we check it. So the potential answer is negative 35 over 2. What I mean by checking, I'm going to have to kind of go down here, is I want to ask yourself, does negative 35 over 2 make any of the denominators equal 0? So your best bet is to go back to your LCD. But if you look back at the denominators, remember it's all, the LCD is a combination of all of them. So my LCD is x plus 5, x minus 5. So my question to you is, if I plug negative 35 over 2 into that x or into that x, does this equal 0? Yes or no?
No.
No. So x equals negative 35 over 2 is the answer. Okay. And I know you're going, okay, what if it doesn't? Well, that's what the next problem's for. I think 2 problems from now is for. Okay. Question real quick before I move on. What would make that 0? What numbers for x here and here would make that 0?
-5 and +5.
Yes. So -5 and +5 cannot be answers. If it's anything else, then it's good. And we did get something that was not -5 or 5, so that is the answer. Okay, but if I was to get an answer that was -5 or 5, I would have to throw it out and say, whoop, this is not an answer. It must be D and E. Okay. We're going to get to that. So if you're confused, it's okay. I am going to go ahead and tell you that since all of our denominators are whole numbers, all the parts are whole numbers, if you get a fraction and you're sure that it's right, the fraction's always going to be the answer. It's not ever going to make that equal 0. Okay. All right. So that said, let's move on. Any questions about this one? I know it's a lot. We're going to continue to do some more problems so you can kind of get the gist of things. Anything? Okay. Let's do the next one then.